Geometry. Analytical geometry talks about the coordinate geometry, whereby you're using points. And it also includes Euclidean on straight lines, and also includes any way, because it's trigonometry, it means that also. But now today's lesson is about straight lines. When a straight line is parallel to x-axis, your gradient is 0. And when a straight line is parallel to the y-axis, your m is undefined. Now let's look at equations that we need to use and remember all the time. On your formula sheet, you'll find this formula. This one is for the straight line, and the other one you may use this if you've got 2 points. But the very m that we are going to talk about most today will be the gradient of the line, because it shows you the slopeness, the steepness of your graph. Now, the gradient of any graph, if we want it, having known the 2 points, we are saying the equation is y2 minus y1 all over x2 minus x1. And once the lines are parallel to each other, their gradients are the same. That means gradient of one line, line 1, the m line 1 will be equals to m line 2. But when the lines are perpendicular to each other, that means if line 1 is perpendicular to line 2, when you multiply their gradients, the product therefore must be equal to -1. But sometimes they need you to show them what is the angle of inclination. The angle of inclination, we make angle of inclination with the positive x-axis. When we do it with the positive x-axis, the equation therefore is m equals to tan of theta, which means that would be the angle of inclination. Or positively, your angle of inclination will be alpha this way or theta this way. That means we are going to use this. But if your gradient is positive, we are going to say that theta is equal to shift tan m, if m is positive. But if m is negative, your theta is going to be 180 minus shift tan positive m. We don't need to write the negative because we've already subtracted 180 from that. Then we'll know what is this angle, because that is going to be an obtuse. But this angle here must be acute. That's how we always write our gradients. Now let's look at the distance. The distance between 2 points is written as this, as you can see it in your formula sheet. Or we may use this, because we shall have squared both sides to get rid of the square root. We are saying this is the perfect way of writing your distance formula. That means you'll square the answer thereafter, so that you find the distance, the d itself. Now, when are 2 lines collinear? They are collinear if they are having A on that line, B on the same line, and C on the same line. Therefore, their gradients must also be equal. Just like when they are parallel to each other. When the lines are, or when the points are collinear, then the gradients are equal. Now let's look at the midpoint. The midpoint is the middle of the point. That means if you want the midpoint, the x plus x1 divided by 2 must be is to y plus y2 divided by 2. And hence this we use in the midpoint theorem, which we use in Euclidean geometry. As you can see the sketch here, this triangle, SQ is equals to QO, SP equals to PR. Therefore, this means that PQ, your PQ must be parallel to OR, if this is the case of midpoint in your Euclidean geometry. Therefore, we are saying that QP must be half OR. That is how this equation should be used. And remember all these equations when you do analytical geometry. Now let's come now to the hints that you need to take into consideration. Hints are these. Always make a quick rough sketch if you are given coordinates without a drawing. And always make y the subject of the formula if you are given a straight line. Number 3, know your types of triangles and quadrilaterals, proving them and or using their properties is the common occurrence in all these things. That means you need to know, if you have got this is an isosceles, what are the properties of a square, what are the properties of a trapezium, what are the properties of a rhombus, or what are the properties of a parallelogram, because those things are properties that which will be all the time be questioned about. Number 4, the angle of inclination is always in relation to the horizontal plane. What does it mean? It means that if I have this and I've got this line, the angle of inclination must be in line with this horizontal plane, which means with the x-axis and the positive x-axis. Or rather, if this is the gradient and there is a line, that must be your angle of inclination. That is the typical type of questions and hints that you need to know when it comes to solving problems in analytical geometry and trig ratios.